In an equilateral triangle ABC, AL, BM and CN are the medians. Forces along BC and BA are represented by them, which will have a resultant represented by which vector? Okay. So let us first understand the sum. In an equilateral triangle, this is an equilateral triangle. Let us say ABC. Okay. In an equilateral triangle over here, okay, AL, BM and CN are the medians. Okay. AL, this is BM and this is CN. Okay. In an equilateral triangle, medians and altitude will be same over here. Okay. So AL, BM and CN. Okay. So we have to find out, okay, are represented by them. So okay, forces along BC and BA, there are two forces, one along BC and the other along BA, okay, will be represented by, okay, the resultant of them will be represented by which of the following vectors. Okay. Let us first find out the force. Let us find out the value of the force between them. Okay. So the angle between BA and C will be equal to 60 degrees. The angle between the any two sides in an equilateral triangle will be equal to 60 degree. So theta over here is equal to 60 degree. So cos theta over here will be equal to half. Okay. Cos theta over here will be equal to half. So the resultant of, let us take any side as x. Okay. Let us take any side as x. So the resultant of BA and BC will be equal to, it will be equal to root of x square plus x square plus 2x square cos theta. I have used this formula. Okay, this is the resultant of BA and BA vector plus BC vector. Okay, I have derived this formula from the vector form, that is the resultant over here is equal to root of a square plus b square plus 2ab cos theta. Okay, I have derived the formula from this 2ab cos theta over here. Okay, which is over here equal to, if I find out this value, it will be equal to root of 2x square, and the cos theta over here is equal to, so I will substitute the value of cos theta later. 1 plus cos theta. Okay, so over here the cos theta over here is equal to half. Okay, cos theta over here is equal to half. So basically it will be equal to root of 2x square. Okay, 2x square. Okay, 1 plus half. Okay, 1 plus half will be equal to 3 by 2. So basically it will be equal to root of 3 by 2, 2 and 2 will get cancelled, root 3x square, which is equal to root 3x. Okay, this will be the resultant of the vector of both this vector root 3x, that is root 3 times any one of the sides. Okay, any one of the sides. Now first of all, let us find out, now this is the resultant magnitude, we will find out the resultant direction. Since both the vectors are same over here, so the resultant will be at the half of the angle, that is an angle of 30 degrees. So the resultant will lie somewhere over here. Making an angle 30 degree with either with BC or with BA vector. Okay, with both this vector it will be equal to same. Okay, it will be equal to same. So with BC vector or BA vector it will be equal to 30 degree. Okay, this is the resultant vector over here. Okay, so clearly the vector that represents this resultant will be equal to BM vector. Okay, clearly this represents will be equal to BM vector, which is, there is only one option which is equal to option number B. But how is the magnitude determined? Okay, how is the magnitude determined? In order to determine the magnitude, what we do is we first find out the magnitude of, or we first find out the length of BM. Okay, now the BM, if I consider this angle over here will be equal to 90 degree. Okay, and when I consider the triangle BAM, this angle A will be equal to 60 degree. So BM will be equal to, BM over here will be equal to AB over here sin 60. Okay, so basically it will be equal to BM is equal to AB sin 60, and any side over here AB, any side over here is x, sin 60 will be equal to root 3 divided by 2, which is over here root 3, which is equal to, I can write this part as root 3 by 2 into x. Okay, so this is BM. So 2 times BM will be equal to 2 times this value, which is equal to root 3x. Okay, which is equal to, that's why which is equal to the resultant, which over here is equal to the resultant. So the resultant over here is equal to 2 times bm. We have got the magnitude as well as the direction. Okay, so the correct answer over here is equal to option number B.